Hi all, welcome to day 2 of general angle measurements in radian measures. So hopefully yesterday that seemed kind of made sense when you're graphing radian measurements in standard position and also finding the coterminal angles, okay? So what we're going to do is we're going to continue with the trend with radian measurement, but today what we're going to do is find the reference angle. So the reference angle is the same as it was when we were finding it with degree measurements. The reference angle is the acute angle that is made with the terminal side and the x-axis. So we're going to talk about that today. Just to remember, if you're retaking Unit 7, then make sure that you fill out that Google form and you're asking me questions that you may have on it because that will be this Thursday and that grade will completely replace. So just a little side note before we get started. Okay, so how can you find the reference angle of a given angle? So that's the whole point of the lesson today. How can you find the reference angle of a given angle? You'll see this is very similar to what we did last week with degrees. We're just doing it with a different measurement this week, kind of just taking our time. So last week you saw the same slide, and it kind of explained what it was, how the reference angle is an acute angle. So let's make this a little bit bigger. So the reference angle is an acute angle that is formed by the terminal side and the x-axis. So acute, terminal side, x-axis. Remember, the reference angle is always positive. Always going to be a positive number. Do not give me a negative number. Okay? And then last week we talked about this part here, the 90 and 360. But today we're going to talk about this, the 2 pi and the pi over 2. So again, like I said last week, the notes down here where it says radians you can absolutely use. I think those are a little bit confusing for me personally. I just like to see how much further I have to go. So let's look at this problem. Let's do some down here. So let's say I have, let's start with 7 pi over 12. We'll start with this one right here, okay? So let's say I have 7 pi over 12. Well, 7 pi over 12, let's think about that. So, I'm looking at it here. I'm going to draw my initial side, which is right here. Remember, my initial side is always on the x-axis, the positive x-axis. And 7 pi over 12, remember this right here would be 1/2. Well, half of pi over 12 is 6 pi. So we're going to go 1/12 more, which is about right here. And there is my 7 pi over 12 angle in standard position. So I've done that part. Okay. Please make sure on the homework and on the homework from last week that there's multiple questions within one question. So make sure you're answering all of them. So I want to now find the quickest way to my x-axis, which is right here. Okay. So it needs to be acute, so I'm going to find the measurement from here to here, okay? And I know that this is 1 pi, so I look at it and say, okay, how can I get 1 pi from 7 pi over 12? How many more pi's do I need? Well, 7, 8, 9, 10, 11, 12. So my reference angle is 5 pi over 12. But some people are going to be like, Lover Chuck, I have zero idea what you just did there. Well, what I really did is just did 1 pi minus 7 pi over 12. I got common denominators. So 12 pi over 12 minus 7 pi over 12. And I got 5 pi over 12. Okay? How can I get 7 pi over 12 to 1? I need 5 pi over 12. So that is my reference angle there. Okay? Everybody okay with that? If you have any questions, make sure you log on to Zoom again, just like degrees. I would prefer for you to keep them in radian measurement when you're graphing, when you're converting. It just makes your life easier. Let's look at number 2 now. So now this is negative measurement. That's okay. I'm just going to go the opposite way. So negative 3 pi over 4. I have my initial side. And then this would be negative 3 pi over 4. Okay? 1/4 of the way between 1/2 and 1. So now I want to find where that crosses closest way to my x-axis. Well, that's going to be this angle right here. So that's going to be that angle right there. So I'm trying to get 3 pi over 4 to 1. So my reference angle would be pi over 4. Again, reference angles are always positive. I'm going to take a lever check. How did I possibly do that? What did you do there? Well, I want to get 3 pi over 4. So I would do 1 pi minus 3 pi over 4. Okay, because I'm going the backwards way. I would get common denominators. So that's 4 pi over 4 minus 3 pi over 4. And I get pi over 4. Okay. Let's do one more just to make sure we're good. If you have questions on the ones I don't do, please log on to Zoom. So let's do number 1. So 5 pi over 2. Well, I have my initial side. Okay. And that's going to go around once, which is 2 pi, which is 4 pi. And then I'm going to go up to here. Okay? So that would be my initial side. And then we wouldn't put a reference angle there. Or what we could do is put pi over 2. Even though it's supposed to be an acute angle, the closest way to the terminal side there would be to go this way or this way. You're going to the same direction. It's perfectly fine. No big deal. Okay? Actually, let's do one more just to make sure we're good. Let's do number 4. So, negative 9 pi over 8. So I have here, right? So I'm going to go past 1/2, past negative 1, up 1/8 more, so to about here. And I want to find my reference angle. Well, again, I'm trying to get to my x-axis. So that angle measurement would be from this terminal side to that. Well, think about it. I'm 1/8 past 1, so the quickest way back to 8, 1/8, or 8 over 8 is 1/8. So my reference angle there would be pi over 8. Okay? So hopefully this helped with reference angle. Again, if you're kind of confused with radian measurements, please log on to Zoom and ask questions. What we're going to be doing tomorrow is doing supplementary and complementary angles in radian measurements. Again, if you have any questions, please let me know. Have a great day, guys.